13 feet ladder is resting against the wall. If the base of the ladder is pulled at a constant rate of 2 feet per second, how fast is the ladder sliding down the wall when the base of the ladder is 5 feet from the wall? So let's think about a ladder on the wall, and this is 13, and this is being pulled at a constant rate of 2 feet per second. And as you pull it, the ladder will slide down the wall, right? So the question is about how fast is it sliding down. Now the simpler picture is basically asking you this. The hypotenuse is always 13, and this x and y, these two values are changing because you're pulling this part. X is increasing, and it's increasing at a pace of 2 feet per second. So let's write 2 for now. We can put the units later. And then the question is, what is dy dt when x is equal to 5? When the base is 5 away from the wall, what is change of y over change of t? Because when it's sliding down the wall, this y is shrinking, right? So the rate which the y is shrinking is really the answer to how fast is the ladder sliding down the wall. Okay, so we have this, and since you have a right triangle and you have all sides involved, it must be the Pythagorean theorem. X squared plus y squared equals to 13 squared. Very good. And that's all you need to get from the geometry. So what you end up with is just this. This is all you need to know in order to solve this question. And to get a relationship between dx dt and dy dt, you have to take the relationship between x and y and differentiate it by t. So let's do that. Let's differentiate by t. Where this prime means d dt. You're differentiating by t. Okay? So you have x squared prime, which is 2x x prime, or dx dt. 2x times dx dt. And y squared prime, this is 2y times dy dt. And the reason you get these dx dt and dy dt is because of this. X is a function of t. X is something that changes with respect to time. And that's inside a squared, so this is really a chain rule. You have to differentiate x squared, which gives you 2x, but then x, which is the inside function, must be pulled out and you have to differentiate it. I could have written x prime, 2x x prime, but since I have dx dt written here, I just chose to write x prime, dx dt instead of x prime. Same thing happened here. Y is a function of t nested inside the square function, so you have to use a chain rule. You differentiate the outside function, y squared differentiates to 2y, whereas y, which is an inside function, has to be pulled out and you have to differentiate it. And I chose to write dy dt instead of y prime, although they're the same thing. You could have written 2x x prime, 2y y prime, that's the same thing. Okay. Alright, so and then on this side, 13 squared, that's just a constant. I don't see any t, x, or y. There's no variable whatsoever. So when you differentiate this, you're just going to get 0. So what that gives us is 2x dx dt plus 2y dy dt equal to 0. And let's see, dx dt is given here as 2, so I replace this by 2, and 2 times 2 is 4, so you get 4x plus 2y dy dt equal to 0. Now let's continue our calculation here. 4x plus 2y dt is 0, so you get 2y times dy dt is equal to negative 4x, and then you divide by 2y. And dy dt is equal to negative 4 divided by 2 is 2, negative 2x over y. Okay? Now, it's almost close to what they're asking for. It's asking for dy dt when x equals to 5. So you have to evaluate this when x is 5. But if you just replace x by 5 and leave the y as it is, then you don't get a number. And if you think about it, if x is 5, then y will also be some number, right? If x is 5, then actually you know this 5, 12, 13 triangle. If you know that, you can know that y is 12 immediately, or you can use this. So you can say that, let's write it as x equal to 5, then 5 squared plus y squared, which we don't know, is equal to 13 squared, which is 169. So if you take 5 squared, which is 25, subtract, you get y squared equal to 144. So you end up with y equals to 12. So what that means is that when dy dt is evaluated when x is 5, y will become 12, and therefore you end up with 2 times 10 over 12, which is like 20 over 12. It's divisible by 4, so negative 5 over 3. And then you have to add in the feet per second, so it will be feet per second. So that's the answer. Okay. Now, you could also rewrite this. Since this is a word problem, a lot of times in word problems, it's nice to write down decimals. So you could also say negative 1.667 feet per second. That would be another way to write the answer. At noon, ship A is 100 kilometers west of ship A. Ship B is sailing south at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 2 p.m.? Alright, so let's see. A is in the west of ship B. Ship A is sailing south at 35 kilometers per hour, kph, kilometers per hour, and ship B is sailing north at 25 kilometers per hour. Now, at 2 p.m., which is 2 hours after departure, because they departed at noon, right? The question is, how fast is this distance increasing? Okay, again, we have to draw a simplified picture, but this is already simplified, right? So let's try to draw the same thing again. And these will be right triangles, right? And then we need to know how fast this side is changing, right? So we need to know this length, how fast that's changing. And I refuse to put any numbers in here because these are changing lengths, right? So when you draw a simplified picture, one thing that you have to remember is never put a number on the picture unless it's a constant. Only when you have a constant number you want to put it on the picture, okay? And if it's changing, then you want to put a variable to it. So I'm going to put x for this, and I'll put y for that, because these are changing, okay? And then we're trying to look at how fast this distance is changing. Distance between the ships are changing. So I have to put a variable here, so I'm going to put z as this distance, okay? Okay, with this picture, well, and actually there's a fixed number here, 100, right? So there's a 100, from A to B, that's 100. And actually, let's do this. Let's draw a dotted line here and put a 100 here. Okay, so that's confusing. And one nice thing about that is because including these dotted lines, you have this right triangle, and this length is same as x. You have a nice right triangle which has 100 on one side, x plus y is another side, and z will be the hypotenuse. So it's a right triangle. We can use the Pythagorean theorem, so that's nice. Okay, so we are going to use the fact that dx dt is how fast this is changing, but that's ship A's location, right? Ship A's distance traveled is x, so if you differentiate it, you get the speed, so that's going to be 35. And dy dt likewise, that's the ship B's speed, so that's going to be 25. And the question is, what is dz dt when or at 2 p.m. when time t is 2? And then the equation you get from the picture is that you have 100 squared plus x plus y squared equals to z squared. Okay? And that's it. This is everything you need from the problem. So at this point you can pretty much forget about the problem. The only thing you have to remember is that the units are kilometers and hours. So your answer at the end of the day should be kilometers per hour. Okay, so let's continue this. We're going to differentiate this. 100 squared prime plus x plus y squared prime, and then z squared prime. 100 squared, I don't see any x or t or y, so this is not a function of anything. It's just a constant value. 100 squared is 10,000, so it's a constant, so it's going to be 0. Now x and y are both functions of t, and you're differentiating with respect to t. So you have x plus y, which is nested inside the square function. So you have to use the chain rule. It's 2 times x plus y, and then make a copy of x plus y, which is the inside function. X plus y is the inside function. You have to differentiate it. Okay, on this side, it's again a chain rule because z is a function of t nested inside the square function, so it's 2z z prime. Okay, then we have 2 times x plus y. X plus y prime means you have to differentiate x and y separately, right? And you have 2z z prime. And if you think about it, x prime is really dx dt, right? That's 35. Y prime is dy dt, that's 25. So these will be 35 plus 25. And because we're trying to find dz dt, which is z prime, we have to solve this for z prime. So let's do that by dividing by 2z both sides, which leads you to z prime equals to 2 times x plus y times x prime plus y prime, but x prime is 35, y prime is 25, divided by 2 times z, and 2 cancels, and you end up with dz dt, z prime is dz dt, equal to 60 times 35 plus 25, 60, 60 times x plus y, divided by z. Okay, now we have to figure out what dz dt is when t is equal to 2. So this looks like an answer, but not really, not yet, because you need to think about what happens when t is 2. Now when t is 2, this is what happens. X becomes, well, t is 2 hours and the speed is 35, and therefore distance traveled by x would be 35 times 2. So if you're running at 35 kilometers per hour, if you're driving a car at 35 kilometers per hour and you drove 2 hours, that would be 2 times 35. That would be 70 kilometers, right? So x will become 70. Y likewise will be 25 times 2, so that's going to be, what is it, 50, divided by z. Now that's a problem. See, since we found out that x is 70 and y is 50, we have to use this to figure out what our z is. So we take 100 squared plus 70 plus 50 is 120, so it's 120 squared equal to z squared. So that would make z equal to square root of 100 squared plus 120 squared. Okay, I will need to use a calculator for that, but let me just use my Python. You can use your calculator, okay? So I need square root of 100 times 100 plus 120 times 120, and that's going to give me 156.20. So this will be 150, was it 60? Let me see. 156.20. So 156.2. That's what I'm going to use. And then I'll still have to compute this using a calculator. So I'm going to use the calculator to do 60 times 120 divided by 156.2. And that gives you 46.1. So the answer here is 46.1 kilometers per hour. And that's the final answer. Okay. All right, the next question. Actually, this is an easy related rates question because the graph, the picture is already given to you. The only thing that you have to do is come up with the Pythagorean Theorem. 6 squared plus x squared is equal to y squared. And because dx dt is 5, and see, the question is, what's the rate of change of y? So it's asking for dy dt when x is 7, right? That's the question A. In B, well, what's the area? Area is 1/2 times base times 6, height, right? So it's 3x. And for this, the question is, what is dA dt when x is equal to 7? That's the question, right? So let's solve one by one. Dy dt, to get this, you should differentiate this. Let's differentiate this. 6 squared prime plus x squared prime plus, equals to y squared prime. 6 squared is a constant, so it's 0. X squared differentiates to 2x x prime. Don't forget, x is a function of t, so you have to use the chain rule. Same thing here, it's 2y prime. And because we're looking for y prime, we divide both sides by 2y to get y prime, which is, well, 2 cancels and you get x prime over y. But what's x prime? X prime is 5. So you end up with 5x over y. And now you have to figure out what y prime is when x is 7. But when x is 7, let's see, when x is 7, what's y? Y is square root of 6 squared plus 7 squared by Pythagorean Theorem, right? 49 plus 36, 49, 36. So that's 49 plus 36, so that's going to be 85. So square root of 85 is what you get. And you have 5 times x is 7. So you end up with 35 over square root of 85 inches per second. Okay. And for this one is actually easy. See, a is 3x, right? So if you first need the relationship between a and x, and then if you want dA dt, you just differentiate both sides. See, a is 3x, so if you differentiate both sides, then the left side will be dA dt, whereas the right side will be dx dt times 3. But since dx dt is 5, this just means 3 times 5, so it's 15. Okay. Now, if this question was with y equals to a number, then that's a different story. In that case, you still have to find the value of x by Okay, so I guess it's still the same. Right. If this question was given with dy dt being a constant value, then it would be a different story. Then in that case, you have to use this to get dA dt. So it will be a more complicated question. The volume of a cone is V equals 1/3 pi r squared h, a 5 feet tall cone. So 5 feet tall means h is equal to 5, right? And the base is increasing, so r is increasing, h is constant. The rate of change of the radius of the base is 0.5 feet per second. What is the rate of change of the volume when the radius is 3 feet? Okay, so here volume is 1/3 pi r squared times 5, because h is 5. So this is 5/3 pi r squared. And given this relationship, the question is asking, what is dV dt? What is the range of change of the volume that's being asked when the radius is 3 feet? And it's given that dr dt is equal to 0.5. Okay, so let's try this. In order to relate these two derivatives, you have to take the relationship between the two variables and differentiate both sides. Now v prime means is the same thing as dv dt. Now pi looks a little scary, but you don't have to be scary because you don't have to be scared because it's just a number, right? Any constant multiple can be brought outside, and you just have to differentiate this. And once you have that, r squared, what's that? R is a function of t because it changes with respect to t. So you can differentiate this and you get what? 5/3 pi, and then r squared differentiates to 2r, and r has to be brought outside and you have to differentiate, so you have dr dt. So you have dv dt equal to this, and since dr dt is 0.5, this is what you get. That's 5/3 pi times 2r times 0.5. But 0.5 times 2 is 1, right? So you end up with 5/3 pi r. That's dv dt. So we're almost there. We can now say that dv dt r equals to 3 is 5/3 pi r with r equals to 3, right? So you have 5/3 pi times 3, 3 cancels, so it's 5 pi. Okay. Now what is this? 5 pi. dv dt, v is a volume, right? So it has the cube unit of the length. Because each length is computed at, has a unit of feet, you have to have cubic units. And because the time is measured in seconds, this should be in seconds. Okay, so that's the final answer. Okay, a point is moving on the graph of y equals to square root of x squared plus 9. The x-coordinate is increasing at a constant rate of 3/2. What is the rate of change of y when x is 4? Okay, so you have x-coordinate increasing at a constant rate of 3/2, which means dx dt is 3/2. Okay, all right, and then it's asking for what is the rate of change dy dt when x is 4. Well, this is again a simple question because your relationship's already given, so you don't have to find it using pictures or anything. It's already given to you. So we just simply differentiate both sides. Now this left side we dy dt, and this one, since x squared plus 9 is nested inside the square root function, and you remember that square root of x prime is 1/2 radical x, right? So this is going to be 1/2 times square root of the inside function, which is x squared plus 9, times you make a copy of the inside function outside and you have to differentiate. Now furthermore, this would be this would be x squared differentiates to 2x x prime. Remember, x is a function of t, so even when differentiating x squared, you have to use the chain rule. Whereas if you differentiate 9, 9 prime is 0, because 9 is a constant. 2 cancels, and you have this, and then x prime is 3 over 2, right? So you have x times 3 over 2 over square root of x squared plus 9. Okay? And therefore, the result is the following. You know that dy dt is equal to 3 over 2x and square root of x squared plus 9. Now, it's asking, what is this when x equals to 4? So that means I have to plug in x equals to 4 here, which is 3 over 2 times 4 over square root of 4 squared plus 9. 4 squared is 16, 16 plus 9 is 25. Square root of 25 is 5. That's convenient. And 4 divided by 2 is 2, so 3 times 2, which gives you 6 over 5, or it's 1.2. Either one will be correct. Okay. So this is our answer. Because the question didn't have any units, the final answer cannot have any units either.